In this presentation, we shall learn about character data type in depth. Okay. Now, before going to learn about this, we have to know some of the basic concepts of character. Character is a data type, and it is declared like character such variable name. Okay, variable name, and you can assign the value or you can leave the value. Okay. Whenever you declare a character variable, a memory location is allocated of 1 byte. 1 byte means there will be 8 bits in there. Okay, we'll write the range for this. Okay, since here nothing is mentioned here, it is a signed system. In signed system, we know that half will be positive values, half will be negative values. We know that here 1 and 0 can be placed same. Okay, here two possible values can be placed, so the value is 2 power 8. Since there are 1 2 3 4 5 6 7 8, total 8 values, this will be 256. Now 256 is divided by 2. The answer will be 1 2 8. So there are 128 positive values, 128 negative values. So your range is 0 to 127 and minus 1 to 128 minus 128. So this is our range. See, this is 128 values. Here 128 values. Here this is positive values. Here it is negative values. Total will be 256. So our range is minus 128 to plus 127. So this is how we got the range. Okay, in signed system we got the answer as this range, right? This range. If it is an unsigned character, then the range is total values, right? Total value is 256. This is the total value. Then the range is 0 to 255. Okay, so some of the interesting things happens in character. Let's see. If I name character as Sunny, okay, so most people think that character is only capable of storing only characters, but it's not the answer, because let me give an example. I can store 10, it will work. I'll prove to you, okay? And for example, in that same variable, if I store A also, it will work. So what happens exactly during this? Okay, from my childhood onwards, I was taught that computers only works in zeros and one, but A is not a number. If A is not a number, how can it be stored? Okay, how exactly it is stored? So there must be something. Okay, and see, we first of all will test this case and test this case. Okay, after that I have to tell about a format specifier. So percentage %c is used for character and percentile %t used for signed integer. Okay, let's analyze what exactly it happens, and we'll come back to here and think why it happens. Okay. See, here I stored character m in a variable called Sunny, and I print using percentile %c as a format specifier. So I'm printing the m which is stored in Sunny. Let's see if it works or not. Okay, a new line. Now you can see that m is placed. So my first question is, if m is stored in there, so we learned from our childhood onwards that computers store data in forms of zeros and ones. So how m is stored? Let's see. See, what I'll do is I'll print what is stored in that. Okay, I'll print percentile %d, which means what is the value in that. Okay, same variable, and let's see what happens in that case. See, now same variable represents a number as well as a character. This is impossible, right? How it works like that? Okay, so the question to your answer is, already we got the answer as m and 77. By using percentile C, you got the answer as m. While using percentile d, we got the answer as 77. So what happens is, for every character there is a fixed binary value. Okay, for every character there is a fixed binary value. Okay, some number. Okay, and here that character is mapped to that number, okay, like this. So this mapping is done by ASCII values, okay. So what what I mean is, for every alphabet, for A, for B, for C, and so on, for every this there is a fixed value, okay. Now how to access these ASCII values? Okay, let's see what is there in ASCII values. You can type man ASCII, okay. Now ASCII, see, it is an American Standard Code for Information Interchange. It's a 7-bit code, okay. We got 77, right? See, you can see here at the top octal decimal hex and character. In character M, you can see that decimal value is 77, okay. So this is how we got the answer. We got one key point here, that is, whenever you store characters, it is stored in form of numbers, okay. Ultimately these numbers are breakdown into binary, okay. So this is the flow how it stores, okay. So my first question is, whenever we store like this, okay, who tells that A should be replaced with 65, okay, who? So it is done by, we have placed it right this, like this code single quotation, right? It is very important, okay. It signifies that it is a character, okay. It is a character, and while compiling, this A will be replaced with 65. Don't believe me, I'll prove to you, okay. If the character Sunny, if I store directly A, it is not valid, okay. Why? Because see, here A, if you put like this single quotation, then it is a character. If you don't put like this, it is a variable. For example, if I store 65, if I store, okay, if I store A equal to 70, okay. Now what happens? We'll see. If I put A in Sunny, if I compile it, I should get error. Why? Because A is not declared anywhere, okay. See, while compiling, I got the error as A is undeclared, because see, if you put quotations, compiler will take care that it is in character, and I have to replace it with equivalent ASCII value. If you put A, then compiler doesn't know what A exactly stands for. Then what I'll do is, see, I'll make as character character A, and I'll equate it to number 70. So now this is very interesting case. Let's see. Now A got the value of 70, okay. Now 70 is transferred from A to Sunny, okay. Now Sunny contains 70 value. Now if you print decimal, the answer will be 70. What happens if you print character? Let's see. Let's compile and run it, and let's see what happens. See, answer is F. So how I got the F? Let's see. Just remember 70 number, and we'll check the ASCII table, okay? See, you can see here F value is decimal 70, okay? You can see here. You can see here F value is 70. We learned that whatever you store in character, okay? Whatever you store in character, ultimately we store ones and zeros, okay, only ones and zeros. So there is a mapping from character to number that is done by the compiler. Now I'll prove you that whenever you type like A in quotations, automatically compiler will replace its ASCII value, okay. Let's see. For this code, I just remove this part, and I'll put a quotations there. First of all, I want to prove that it will not give any error. See, okay, A, and I have saved that file, and see, there is no error. Now I want to stop here, and make it as, I want to compile up to here and let's see what happens. I want to display this character youtube.s file. Okay, so usually we'll use hyphen s, which means that after translation it stops. Now this is the assembly code. Okay, usually compilation has many stages. It's not in the scope of this lecture, but you can see that here 65 is there. Okay, 65 is there. So 65 is nothing but ASCII value of capital A. Now I'll put capital B. Now if it is 66, then you can say that it is working, right? Okay, we'll just compile it and we'll open the file. See here, the answer is 66. See, compiler automatically replaces the values which are put in the quotations. Okay, so this is the most fascinating thing which I have seen in programming. Okay, so I proved that compiler replaces what you put in the quotation. Okay, now if you put a and b in a quotation, it is not valid, because, say, use your common sense, we have to develop this. It's ASCII code, so there are so many combinations are there. Even for one also, for character one also, there is an ASCII value. Okay, it is 48. Okay, you can check out. So if there are infinite numbers are there, for infinite numbers we have to develop all the ASCII values, so it is not possible. So what they have said that, okay, they fix it from a to z. Okay, small a to small z, 0 to 9. Okay, and some of the special characters. Okay, now when you study arrays, strings, pointers, then you can easily store these values using this small ASCII table rather than developing a big logic, and that is not feasible also.